manipulation. بدي ارجع لهون لورا شوي. اللي هو اذا بنعمل threads we use very large number of threads مثلا 10 20 30 50 100 بنقدر نعمل وبنشوف كيف الثريدز بيشتغلوا مع بعض بشكل ممتاز وبنشوف الكريتيكال سكشن هذا اذا صار عليه deadlock او لا. فانا we have to make sure انه we don't get in deadlock لما يكون في عندنا multiple threads. If we can do that يعني إذا قدرنا احنا نشتغل الشغل هذا بشكل ممتاز then we actually master the client server stuff. قبل ما أدخل هنا بالdistributed systems let me just make one summary slide, quick summary من الأشياء اللي لازم نعرفها. Must know how to create sockets on clients and server. Okay, هذا this is one. Establish connection. أكيد هذا الآن بتعرفوه. Establish connection between clients and server. Again, establish I/O communication input and output between clients and servers. So that's important. Once we start doing that, then create multiple clients, connect to a server, create multiple clients and multiple servers. Okay. Examine bottlenecks using multiple clients. Then finally create threads and use threads for multiple clients. سمينظل عندي عمر علاوني. عمر السيات بعد few minutes I will make a quick quiz and you will be the only one who will do the quiz. الناس اللي اجوا طلعوا. That's just about this topic, distributed databases and client server architecture. Okay, so distributed databases, a distributed database, it's a collection of multiple logically interrelated databases. يعني مش tables but databases distributed over a computer network. Distributed database management system, it's a software that manages a distributed database while making distributing transparent to the other. Okay, applications, users access distributed database through applications, certain applications. Let's see how we'll do that. So we have a communication network. And our database is in different places, in New York, in Chicago, Seattle, Orlando, Florida, San Francisco. That's what actually Google has. It has all of these distribution. So this, however, it has a centralized database here, and all of these guys they access this database. If I want to do truly distributed, now this is not truly distributed. We have one global database. It's a very large database, and our clients all over, they will be accessing this database through the communication network. As long as I have the IP address here and the port numbers, then I can access my database. In truly distributed, we have databases all over the world. With these databases, they have all information I need about people, about identities, about documents, about money, everything here. So the applications here, now when I say applications, it's not an app, I am talking about application. Local application, it's an application that does not require data from other sites. I'm local. Just like if I go back here, there is an application here. I may only need my local server, or like this here. I have a client that communicates with this database, but it may also connect to the database here. Global application, it's an application that does require data from other sites. Today, if I will do the Google search, my Google search actually requires information from all over databases all over the world. Now, the distributed databases can be either homogeneous or heterogeneous. Homogeneous, يعني متشابهات. All sites have identical software, like Microsoft SQL, for example. All are aware of each other and agree to cooperate in processing user requests. كلهم, every database will accept the request from any other client. Each site surrender part of its autonomy in terms of rights to change schemas. يعني في تفاهم. I am on this site, for example, here, and if this database need to make some work here, it is allowed. I can do that. The heterogeneous مش متجانسات. Different sites use different schemes and different software. For example, one site can have an Oracle, the other site SQL, the other site has Firebase or Sybase, and so on. And difference in schema. One schema has one type of ERD, the other database has different type of ERD. So that's could cause some problems. Different software will cause problems when processing transactions. So there's an issue here. So we have to be careful when we have heterogeneous databases. Sites may not be aware of each other and provide limited facilities for cooperation. And cooperation between databases is limited. This is an example of homogeneous database where we have some global user here. We have local user on this distributed database. That's global. So, and this is the distributed database. And we have here 1, 2, 3, 4, 5. These are databases, but all of them are similar. So from the perspective of a user, we will look at all of these as one global database, but it's distributed. That's the architecture here. Whereas the heterogeneous database, I will have a database it's one, let's say, and it's different than Y6 or N. All of these are different databases, but we can all connect to them through this network. There is a network that allows us to communicate. And one of the types of databases is called federated database systems, where there is some global view or schema of the federation of database that is shared by the application. There is a global view of the schema. So the global view, you could see the schema of your database, the tables, the customers, some information which can be viewed by all. And each server is an independent and autonomous centralized database. Each server has its own local users' transactions. And multi-database systems, no global schema, builds schema as needed. Everybody makes his own database schema. The problems with federated database systems, they are different in data models, network and hierarchical differences in constraints. What are the constraints which are imposed upon each database? Differences in query languages. You could have SQL 89, 92, 99. These are different versions of the SQL language, such as each has own set, not one set here. Own set of data types, comparison operators, etc. This is a federated database architecture, just for our own view. We have some external schema, federated schema, and then you have export schemas between the federated. So there is lots of communication going on, and the management of this type of database is very difficult. Now, the functions of distributed database management system. One is extends the communication to allow the transfer of queries and data among sites. Let's say I have a query, for example, I have, let's say, select some, let's say, assume that I have something called unique ID from let's say XYZ, where XYZ defines my global database or distributed. Then with this select statement, this unique ID will go for all databases and find the solution. The best example of this, let me share something else now. Let me share my screen and I will show what we mean by that. That's my screen. Now I want to show my Google. And in Google, whoops, that's where I have. That's not what I want. Yeah, here. For example, I want to search, I would say, meaning of controversy. اللي هو controversy يعني الجدال أو الاختلاف. Meaning of controversy. Look, now when I say search here, and I will say all here. Look, what this did to me, it says I have 1,320,000, actually no, it's 1,320,000,000 results. It's 1 billion results in 0.55 seconds. What did this do? It just put this word controversy, And as an SQL statement, I am select or find or view or import this controversy. And the system has spread this query among hundreds of thousands of servers, hundreds of thousands, maybe a million server. That's why we got the result in 0.55 seconds. It's not even 1 second. 0.55 seconds, which means 550 milliseconds, I was able to get 1 billion results, 1 billion point 3 results. That's very, very, very large number. And the only way we could have done that is with this statement, which is the select among from all available databases. Select from all databases this XYZ or controversy, as I said. Now, to do that, you extend system catalog to store data distribution details. Okay, so the first thing, this goes to one small server. This small server will find the catalog for all the databases and send this to all the databases I have, which means everyone has its own IP. So I have a list of all IPs accessible to me, and each one of them will get one statement from select unique ID or select controversy, if you will, just like the example I have just done, controversy from all available databases. You extend concurrency control to maintain consistency of replicated data. So if you have data coming the same, you will just take one, ignore the other. And the recovery services to take account of failures. What happens if something fails? Let's say, okay, if among these servers, 1,000 of them did not respond, big deal. I can consolidate that with the rest of the servers and I will get my results as soon as possible. Okay. Now there is something called synchronous distributed database. Synchronous means all copies of the same data are always identical. Let's say if I have a database, for example, let's say update record number 1 to 10 in DB in DB, let's say 1. This will lead to updating same record on all other DBs. So if I come to either one database, I update the records from 1 to 10 with certain values, then this will lead to updating same records from 1 to 10 on all other databases. All other databases will have the same update. That's what's called synchronous distributed. And data updates are immediately applied to all copies throughout the network. That sometimes takes some time, extra time. It will help keep the data integrity. Why? Because at any point of time, let's say record 10 field 11, e.g. if this field 11 record 10 is, let's say it has the value x equal 10, means that all DBs must have 10, 11 equals 10. So at any point of time, that's what integrity means. If I want to see if my data has kept its integrity, يعني ما صار عليها مشاكل وخربطات، فباجي بطلع let me check certain value x اللي موجود بريكورد 10 field 11. If this is 10, then I go and check all other databases. I must find the same value. If not, that means something wrong has happened. It does have overhead. Why? Because of the synchronous update. Synchronous update means اللي هو الابديت تحديث المتزامن في نفس الوقت. Slow response times, of course. Why? Because whenever I request data from one DB, I have to check that all DBs provide the same result, which means it's slow. That's the bad thing about distributed databases, synchronous, but the good thing is that I'm always sure what I'm reading is valid and correct. The asynchronous database systems, could be some data inconsistency is tolerated. The data update propagation is delayed. I can wait until the end of the day when I make when I synchronize the data and I make all the data is the same. Data integrity exists, but it's slow. Overhead is much less and faster response time. So that's the good thing about asynchronous DBs, is that they are less overhead and fast. Okay, these are some advantages of distributed databases. Your management of distributed data with different levels of transparency, distribution, or network transparency, which means you don't see the databases. All you see is one global view. Refers to freedom for the user from the or freeze, or it's really freeze the user from the operational details of the network. I don't care about how the network is composed or created, but I do have my application and get my data from wherever I want. Just like here when I just showed this, I don't really care where these 1 billion results came from. All I care about is I want to search for controversy, and there I found it. That's what's important. Replication transparency. Copies of data may be stored at multiple sites for better availability, performance, and reliability. Now, the same data, I can keep it in many places. It doesn't have to be every data on all databases. You can have an algorithm. Actually, with our client server architecture, we can do something like this. Assume that I have these databases. We'll call this DB1. And I can have, let's say, 2, 3, 4, 5. So this is 2, 3, 4, and 5. And assume that I have an operation here. I want to store today's gold price. For example, today is which is November 21. So today is November 21. There is a gold price, and assume that the gold price is okay. Let's say it's $50 per gram. And I will call it GP, gold price. So I want to make it like a real example. Now I want to store this on the database, and here is my my network. Let me
لسه انت اتغديت؟ لا والله الصبح على والله انا ميت جوع.
والله سوي الميوت يا معلم. mute yourself اللي بحكي. So let's say here I have my cloud. Okay, so now I send this to my network. And I'm giving my network the instruction to duplicate this value into 3 places. So it will send from here to DB1. It says GP equals 50. And I do from here also to DB2. Similarly, I send this there. So I'm giving my system the instruction. My network is every time you want to update a value into the databases, choose 3 databases. That can be configured, which means the 3 values. Why 3 not 2? Because I can do voting. If I get 3 values, when I say now, get me here, it says get GP. So I have a query to the network. I say, get me the prices. So what will happen? This will find where is GP stored. It's in DB1, DB2, and DB5. So it will get the value. And it will get it from here too. And we'll get it from this one as well. And we'll send the result. سكر الميكروفون يا. Okay, I get the result here. And I will get the value GP equals 10 or 50. 50. Assume now this guy for some reason got the value instead of 50, got it 45. and this has 50, and this has 50. Here, this will say get GP. So that's the reason the network saved the GP value in 3 databases. And when I requested the GP value, the gold price, it got me these from 3 databases, but it got me 50, 50, 45. So what do I do? What do I get back to the to my client here? Here is my client. He will get the value, take the majority, make majority vote. Okay, the majority vote now, which is equal to 50, and therefore here GP equals 50. What if I had the case where I had this 45, 45, 50, 45? So I get the result 45. Or I get everyone has different value, 50, 45, and 40. Then I say I cannot make a decision because it has to be either 2 or 3. Or I only take it only if 3 are valid values. So this is the issue here, the main issue, which we're talking about the distributed databases. Now, if I have another client who says, send another value, let's say the weather today, the temperature today, he will send it maybe to DB2, DB3, and DB4. So in this case, we will get the results from these 3 databases. At least 3, we usually say. Now you can do more, but it's sufficient to have the data in 3 different databases. Now, of course, increase the reliability and the availability. I just showed the example. The performance also, because the database is fragmented. Now, if I have request for GP and request for another variable, so 2 transactions will go to these databases in parallel. So I have good performance and so on. So it's easier expansion. I can expand the databases as much as I want. Now, of course, software will be costly and expensive. Processing overhead, data integrity is an issue, and the response is slow. We know that. And with data fragmentation, or data is fragmented and sent all over the place. And there are different schemas to store fragmented data. I'm not going to go into the details. What I will be doing mostly is this one here. That's what I will be talking about for the quiz, which I will do right now. So what I want you to do, keep with me now here. Question. Just like the previous example, assume we have 5 distributed databases, systems, clients access the DBs and through the network. Update must be done to 3 different DBs. data retrieved must be brought from the 3 DBs. The data requested is accepted with majority vote. Now consider the following. 1, store the value x equal 10 in DB1, DB2, DB5. 2, store the value y equal 20 in DB1, DB3, DB4. An error an attack on DB1 causes the values then and y to become the values x to become 20 and y to become 10. Okay, and also I have an attack on DB5 makes x equal 15. Your question is, if a client requests the values of x and y, then the final result on the client side will be what? Will be x equal y equal. Okay, so now this is the for you, this is the question. Solve this question and send it to me via WhatsApp immediately. Within you have 7 minutes to do that. Go on. Okay, السلام عليكم. عليكم السلام ورحمة الله وبركاته. حيا الله.